Welcome to today's video on Pythagoras Theorem. You should have checked through your notes already and discovered some information about how to use Pythagoras Theorem. So today is more a recap and an exam question so you can understand how to apply this. So if you remember, in Pythagoras Theorem, it's always about right-angled triangles. And we're given the formula c squared equals a squared plus b squared. That is, the square on the hypotenuse is equal to the sum of the squares on the other two sides. And the hypotenuse is always the side that is opposite your right angle. So today we're looking at the converse of Pythagoras Theorem, and that is proving that a triangle is right-angled, proving that we have a right angle. Now this is very useful in industry, technology, engineering, carpentry, building, anything that requires a perfect right angle. So we're going to start with the very basics. If we take a basic triangle, a 3, 4, 5 triangle, which you'll find is a famous one, quite common and used for examples all over the world, but also used in engineering. Right, what we're saying is that 5 squared is the same as 3 squared plus 4 squared. Now you'll notice I've not put an equal sign in. I've got to prove it before I can add that equal sign in. So what I'm going to do is put in 5 squared, which is 25, and then put in my other numbers. 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. So we can now say 5 squared equals 3 squared plus 4 squared. Hence, a right angle. And this is the format that we're going to take forward into all our questions. So what I'm going to do now is have a look at a question from the 2019 paper. So this is the last paper that people sat, and it's paper 2. So the 2019 paper 2, question 11. Students were told that a diagram shows 3 places, A, B and C. We don't know if it's right angled, so I'll take that right angle out. You're told we've got 600 metres here, we've got 650 metres here. You're told it's the course for a jet ski race. They're going to go from A to B to C, and that C is due north of B. Now, it's also handy here to think about bearings and compass points. So if you think about a standard compass, we have north, south, west and east. I'm sure a lot of you learned it as never eat shredded wheat. And these are the bearings: 0, 0, 0 for north, 0, 9, 0 for east, 1, 8, 0 for south, and 2, 7, 0 for west. Now, bearings are always given as 3 digits. That's so that you always know you haven't missed something when you hear a bearing. And they're always at the right angles. So if we're saying that something is due north, then if something is to the east of it, we're expecting 90 degrees, and if something's to the west of it, we're expecting 90 degrees. So this is our hint that we're looking for Pythagoras in the question. The question asks us to determine whether B is due east of A. So the wanting to know is that east That's supposed to be a question mark, honest. Actually, they want to know if that's west is B due east of A. So that would be west. Right. Now they also give you a little bit of information about the total course length. And rather than waste the time working that out when we actually just want to work with the Pythagoras bit, I'll just write the answer to that part in. And it's 250 metres. So what we're going to do is substitute this information into our formula. So we have 650 squared, and we have 600 squared plus 250 squared. And we're going to figure out what all this comes to. Now, on your calculator, you'll just stick it in and get an answer. So I have done that already, and I have got 422,500 for 650 squared. For 600 squared, I've got 360000, and for 250 squared, I've got 62500, which when you add it together gives you 422,500. And as you can see, they are the same. So we can say, yes, B is due east of A by the converse of Pythagoras. As I say, that was an exam question, so that's the hardest version you're going to see of those questions. If you want any more practice, go to TJ Maths Nat 5 book, page 44 to 49. This particular topic is page 46.